periodic table. So a little bit about history here and what we know about how the periodic table is put together. There were several different scientists that worked together to help organize the elements, but Mendeleev, Dmitry Mendeleev, a Russian scientist, was the one that's really credited as the father of the periodic table. Okay, so Mendeleev, don't know how to spell it, but you know, it's here, so you guys can always look here. It's not a big deal if you don't know how. But he is, one thing you'll want to notice, he is the father of the periodic table. Okay, so he's given credit for designing the periodic table that is probably the closest to what we use today. Okay, it's not exactly the same, but he started using patterns and putting what at that time, back in 1869, what they knew about the periodic table and the different elements, and he started using patterns to put these together, and then repeated those patterns over and over with the properties. If he couldn't find that an element fit in, he left a hole there where he thought maybe an element might fit in. Okay. So the holes that he left were later filled in with elements that had not been discovered yet. So the modern periodic table is pretty much arranged very close to what he did. He had it in the order of atomic mass, but now we have the periodic table in the order of atomic number. So that's the slight bit of difference between what Mendeleev did and what we have now. Okay, so a few switches, but overall, that's why he's been credited for the periodic table. So how is this organized? Well, we've already talked when we talked about electron configurations how we have 6 different rows, or 7 different rows here, excuse me, and these are the periods. So every, or an energy level, as we mentioned earlier in the chapter. Groups then are the ones that go down. You can see here that these are labeled with Roman numerals 1A, 2A, 2B, 3B, etc. Typically now, this is how they used to number them. Now we just number them 1 all the way over here to 18. So this will be group 18. This is group 17, 16, 15, 14, and 13. And that's usually how we talk about them now. And then these are 3 through 12. Okay, so that's the periods and the groups. We've already talked about this a little bit too, the important information. Atomic numbers are number of protons. Mass, atomic mass, is going to be the average atomic masses of all the isotopes. We also typically see the element name, the element symbol, and those are the basic things that we see. So the different parts of the periodic table, we already talked about how over here our first 2 rows are going to be the S section of the periodic table. The middle section 3 through 12 here is the D section, and then over here is our P section, and down below the 2 rows here are going to be the F section. Okay, so those are the different parts. You can see also here that mostly metals are on the left side here in blue, and also the F section, because the F section would fit right in here if we expanded this out. Then we have what are called metalloids that are in the green here, or kind of in between. They have properties of both metals and nonmetals. And then the nonmetals are all over here except for hydrogen. And hydrogen's atomic number is 1. So we stick it here, but it really fits over here in group 17 too. Okay, so those are the different parts. Again, the 2 rows at the bottom are the F section. If we would stick them into the periodic table, it would make the periodic table really wide. And so typically we don't look at it and see it this way with the F section in here. We just drop them down below so that we have a little bit more room on our paper instead of having such a wide periodic table. Okay, so that's why when we do our electron configurations, it's 6S and then F14 and then 5D and 6P. Okay, because that's what it would look like. Okay, and we talked a lot about configurations already, but if we look at our end of our electron configurations, we should be able to figure out what group these different elements in. So these are all halogens, they're all group 17, so if you look here, they all end in P5. This one's in the 2nd row, this one's in the 3rd row, this one's in the 4th row, this one's in the 5th row. So you should be able to start picking up on patterns and seeing those types of things as you see configurations. Okay. And again, we've talked all about this, the differences with our S's, our P's, our D's, and our F's. And then our filling orders we've already been through also. I guess I should have used these slides earlier. Okay, so this is another way to look at how we did our electron configurations. Okay, and then our noble gases over here at the end. Okay, so other things that I would like you guys to know about the periodic table is that group 1, let's see if I can get a better picture. There aren't any good pictures, are there? Right here, group 1, these here are called the alkali metals, ALKALI. Group 2 is the alkali earth metals. Sometimes you'll see these written as alkaline metals too. Alkali earth is more common, but sometimes you'll see them as alkaline. Okay, so you need to know the names of those two groups. The D block are the transition metals. If I can spell here, transition, this is an I. Metals, so you need to know groups 3 through 12 are the transition metals. And then you need to know group 18 is the noble gases. And you need to know that group 17 is the halogens. So those are the groups that you need to know. Typically these groups all in here are named by the first element at the top, so the oxygen group, the carbon group, things like that. Okay. So those are the groups that you do need to know. Again, make sure you understand the metals are to the left, nonmetals are to the right, and then the metalloids are in the middle. So those are some of the properties that you need to know for the periodic table.